Good morning everybody, I am Sridhar Reddy and today my topic is atomic radius and variation in the group and the period. What is the atomic radius? We have to discuss, then how it varies in the group and the period. In order to know the atomic radius, I am taking the one atom, sodium atom, atomic number is 11, electronic configuration is 1s2, 2s2, 2p6 and 3s1. Here if you observe 1s2, 2 completely 2s2, 2p6 and 3s1. Here 1, 2, 3 are called as the principal quantum number which was given by the Niels Bohr. What is the principal quantum number says or 1, 2, 3 says? 1, 2, 3 nothing but the sodium will have 3 orbits, 3 shells. Let us take it. I am taking first shell, second shell, third shell. In the first shell we have 2 electrons. In the second shell we have 8 electrons. Last shell, which is called the valence shell, we have the 1 electron, 3s1. So this is the electronic configuration and representation of the shells you are having. Let us take here. Here if you observe, what is the atomic radius? The distance between the center of the nucleus to the valency electron in an atom is called as the atomic radius. The distance between center of the nucleus to the valency electron in an atom is called as atomic radius. How to calculate the atomic radius? What are the units you are having? The units will be the angstroms and nanometer, where 1 angstrom is equal to 10 to the power of minus 8 centimeter. 1 nanometer is equal to 10 to the power of minus 9 meters. So nothing but radius, nothing but distance can be calculated taking the centimeters and meters. Particularly atomic radius can be calculated in terms of the angstrom. 1 angstrom is equal to 10 to the power of minus 8 centimeter. 1 nanometer is equal to 10 to the power of minus 9 meters immediately. How to calculate atomic radius? What is the distance here to here? What is the distance? How to calculate this one? The atomic radius cannot be calculated directly. It can be calculated indirectly by taking the two atoms, and the two atoms are supposed they contacts with each other. Now I am taking the two atoms like this. They are contacting with each other. Then it is very easy to calculate the internuclear distance. What is the internuclear distance? The distance between one nucleus to another nucleus is called the internuclear distance, and the internuclear distance can be calculated by using the X-ray diffraction method. Whenever we calculated the internuclear distance, let us take it half of the internuclear distance. Nothing but this sphere you take from here to here. This sphere you take here to here. Nothing but distance between the center of the nucleus to the valence electron. Distance between the center of the electron to the valence electron. That's why atomic radius can be calculated by taking the internuclear distance. Half of the internuclear distance between the two adjacent atoms which are contact with each other, and the radius is that value is called the atomic radius. So it is a indirect method. Directly we cannot calculate the atomic radius. Indirectly we will calculate the atomic radius by taking the two spheres, two atoms which must be contact with each other. Then internuclear distance can be calculated by using the X-ray diffraction method. Whenever you know the internuclear distance, just you half it, immediately the value will be equal to the atomic radius. For example, here in case the internuclear distance is 4 angstrom, then the atomic radius will be the half nothing but 2 angstrom. Like this, you will calculate the atomic radius of the different atoms immediately. Based on the nature of bonding, atomic radius is classified into 3 types. Number 1, crystal radius. Number 2, covalent radius. Number 3, van der Waals radius. All 3 are important for your MSET examination, particularly MSET NEET examination. He asks you all crystal radius, covalent radius, van der Waals radius. What is the difference? Radius you are saying, your atomic radius you are saying. What is the difference between these 3? Crystal radius is applicable for only metals. Immediately the radius is called as the crystal radius. Non-metals are there. The non-metal radius is called as the covalent radius. Okay, metal and non-metal is finished. What is the need of the van der Waals radius? Van der Waals radius is applicable for the solids. Whenever the solids are there, immediately the radius is called as the van der Waals radius. How to calculate this one? Same thing. Half of the internuclear distance between the two adjacent metal, then it is called as the crystal radius. Half of the internuclear distance between the two adjacent non-metals is called as the covalent radius. the half of the internuclear distance between the two solid, then it is called as the van der Waals radius. So different radius immediately. Among the three, which will have the high value, what is the order of the radius? Very, very important. The order of the radius, if you observe, van der Waals radius is greater than the crystal radius, is greater than the covalent radius. So this is the order. Many times you ask in your examination, arrange the increasing order or decreasing order of the different tests of the radius you are having. Van der Waals radius is greater than the crystal radius is greater than the covalent radius. If you compare the van der Waals radius and the covalent radius, van der Waals radius is nearly 40% higher than the covalent radius. 40% higher than the covalent radius, nearly 2 to 3 times given in your examination. Now let us discuss how it varies in the group and the period. How it varies in the group and the period. I am taking the group. I am taking first A group elements, alkaline metals, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Francium is a radioactive element, that's why I am taking from hydrogen to cesium. Let us take atomic number 1 and this will be the 2. Just you add 2, 8, 8, 18, 18, 32. You will get the remaining elements which are the elements present in each period. 2, 8, 8, 18, 18, 32. Already you are familiar. Period elements, if you take first period 2 elements like that, 2, 8, 8, 18, 18, 32 you add, you will get the remaining elements, you will get like this. Now I am writing the valency electronic configuration. Just you add 37 plus 18, 55. So this is a valency, I am taking the atomic number, valency electronic configuration. It is the 1s1. It will be the 2s1, 3s1, 4s1, 5s1, 6s1. Look at here. What you have to say? In group, how we have to move? In a group, we have to move from the top to bottom. In a group, how we have to move? We have to move from the top to bottom. As we move top to bottom, look at here, atomic number increases rapidly. Atomic number increases rapidly. But the differentiating electron, new electron enters into the different principal quantum number. So here principal quantum number 1, nothing but it will have one shell. 2, 3, 4, 5 and the 6. So what you are writing, whenever he asks you the atomic radius, what you have to say? In a group, as we move top to bottom, atomic number increases, the differentiating electron enters into the new principal quantum number, immediately number of shells also increases. So here you will have 2 shell, here you will have the 3 shell, here you will have the 4 shells, last I am taking here you will have the 6 shells. Now, what is the definition of the atomic radius? Atomic radius is nothing but distance between the center of the point to the center of the nucleus to the valency electron. Here in this case it is this much, this much, this much. If you observe atomic radius top to bottom, what happening? Clearly it is increasing. That's why in a group, as we move top to bottom, atomic radius increases. Why it increases? Because atomic number increases, differentiating electron enters into the new principal quantum number, number of shells increases, ultimately the distance between the center of the nucleus to the valence electron increases. So in a group, as we move top to bottom, atomic radius increases. If you are perfect with the atomic radius, remaining periodic property we can explain very easily. Look at here, remaining property will be ionization potential, electron affinity, electronegativity. Atomic radius increases, ultimately remaining 3 will be decreases. Ionization potential in a group top to bottom decreases, electronegativity decreases, electron affinity also decreases because atomic radius increases. These atomic radius and these 3 properties are inversely proportional to each other. That's why it is a group, very simple. In a group, as we move top to bottom, atomic number increases, differentiating electron enters into the new principal quantum number, number of shells increases. That's why the distance between the center of the nucleus to valence electron increases, ultimately atomic radius increases. If atomic radius increases, ionization potential, electron affinity, electronegativity decreases. Now, in a period I am taking, second period I am taking lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So, in a period, how we have to move? We have to move from the left to right. In a period, as we move left to right. Look at here, atomic number 3, 4, 5, 6, 7, 8, 9. Atomic number increasing by 1 unit. Valency electronic configuration 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, so on. Finally, 2s2, 2p5. This is electronic. 2s2, 2p3, 2s2, 2p4. Ultimately 5. Now look at here. The differentiating electron entering into the 2s orbital, nothing but principal quantum number 2, 2, 2, 2. Nothing but number of shells will be the same. In a period, as we move left to right, number of shells is not increasing. Number of shells will be same. But what happening? Here 3 nothing but 3 atomic number 3 nothing but it will have the 3 protons. Here fluorine will have the 9 protons. Protons are high. Ultimately nucleus attraction will be high. Nucleus attraction is high, immediately size will be decreases. Come on here once again. As we move in a period left to right, differentiating electron enters into the same principal quantum number 2, 2, 2 only, 2 shells only. Here 2 shells, here 2 shells. But as we move left to right, here nuclear charge increases, number of proton increases. Proton increases nothing but they drags the valence electron towards the nucleus. Ultimately size will be decreases. That's why what we have to say simply we are generalize the phenomena. In a period as we move left to right, the differentiating electron enters into the same principal quantum number. Number of shells will be same but protons increases, nuclear charge increases, ultimately size will be decreases. That's why in a period as we move left to right, size will be decreases. Whenever atomic radius is decreases, ionization potential, electron affinity, electronegativity will be increases. So this is a very, very important concept. In the intermediate, there is a 8 marks question. What is the periodicity? How it varies in the group and period? Atomic radius, electron affinity, electronegativity, ionization potential frequently gives you. If you are perfect with the atomic radius, we will write the everything. Thank you.